Okay, is there any questions about anything else? Okay, so last class we talked about secure keys, or started talking about it. What I'll do is I'll just wrap that up, and then we'll move on to two more topics. So we're going to talk about, so secure keys is like how you log in. We're going to talk about something called OAuth, which is, I say have two apps. Say I have Google and I have a travel planner. I'm logged into both of them, and I want the travel planner to be able to access my Google Calendar so it can dump stuff into it, or it's going to go through my Gmail and look for like booking reservation emails and things like that. So how do we authorize one app to access another? That's called OAuth. And then the final topic we'll talk about is single sign-on. So that's like, instead of the website managing its own identities, it uses Google. So I log into Google, and then Google tells the site who I am. And it turns out that that looks a lot more like OAuth than it looks like secure keys. Even though it's about logging in, it looks almost the same as OAuth. But anyways, we'll get there. Okay, so secure keys, just to remind you, I keep calling them secure keys. I don't know why. I think there's a company called Secure Keys. I always confuse it, but it's passkeys. That's the right word, so I'll just fix that. Okay, so I actually kind of forget how far we got. I know we didn't finish it, but we'll go through it as a review and then remind myself how far we got. So we started writing out the protocol. So this would be the registration protocol. So we have the user. The user has a browser, and the browser, or the computer that she's running the browser on, also has like a secure enclave. Okay, so these two things would be on Alice's MacBook or her iPhone or Android or whatever. We have the internet and we have the server. So the user says, I want to register. Here's my username. I want to use a passkey. What the server does is it picks a challenge. So random, unpredictable number. Then what the browser is going to do is it's going to go to the secure enclave, and it's going to say, okay, I want you to create a passkey for this website. Okay. And so it's server.com, and choose some randomness. Give me a key. That's going to be the secret key. Then give me the public key that goes along with it. And I'm going to send the public key ultimately to the server. And that's how the server is going to identify me. So instead of me having a password, I'm going to have a public key. Okay. Yeah. Is a question? Yeah.
So let's say we generate passkey from a MacBook.
Yeah.
And I have my account on my phone as well.
Yeah.
Would that sync up with the same passkey?
No. So passkeys live in an enclave, so they're bound to that device. Yeah. So if I log in with a passkey from my MacBook and then I switch to my phone, I don't have that passkey anymore. Yeah. So they aren't synchronized or anything like that. They're literally inside this secure device type of thing. Yeah. So another thing I should say about passkeys, it wasn't maybe clear. This is usually never your primary authentication mechanism because you can't move to another computer. Like say I create an account from my computer, I use a passkey, then I lose my computer. I'm never going to get back into that account again. Yeah. So usually what it is it's a secondary method, not like two-factor. Two-factor is like it layers something on top of passwords. This is more like I'll still have a username password underneath everything, but then I'll have this as my main mechanism for logging in going forward. And if my username password has two-factor and all of that stuff, I can basically skip it. So this is kind of a two-factor because I'm proving, it's actually kind of one factor, but it's a one factor of what I have. So I'm proving that I have this computer. But the fact that I can unlock it shows that I know the password for the operating system. And in Apple's case, what they'll do is they'll require a password in order to get the enclave to do something for you. And so it ends up being kind of two-factor in terms of something you are, your biometric, and something you have, which is this specific device itself. Okay.
So I'm guessing Chrome is doing it in a very different way then, because what I have noticed is, let's say I'm using an Android phone with Chrome. I generate a passkey on Chrome. It syncs up with the iPad as well, so I'm guessing it's a fundamentally different way.
Yeah, so the passwords will sync up, but passkeys, if passkeys are stored in an enclave, it won't sync. So it could be that it's just storing it in the cloud. Yeah. So it's not using a secure enclave. So this is very influenced by Apple's model. That's the model I know. I don't really know how other people do it. So that could be an explanation, or it could not actually be a passkey. It could be something kind of similar, but technically not a passkey, because, yeah. Okay, so we get a challenge. We register the key. So the key part here is that the key is bound to this server, okay? So every server will have a different, it's called relay party specified here, and it will generate a different key, okay? So every server I go to, I'll get a different key for. So if I visit 10 servers, I'm gonna have 10 different keys. So it's not like I have one public key that represents my identity and I give it to all 10 websites. I generate a specific key for each of the 10 websites. This is how it differs from things like, we didn't talk about it, but in TLS or HTTPS, you can do mutual authentication. So in mutual authentication, both parties have certificates. They both authenticate. It's also based on passwords. But in that case, I have one certificate for me, and I'm going to give that to every single website. So every website will have the same public key for me. Here it's each website will have a different public key. Okay. The next thing I want to do is I want to get this challenge message signed. Okay. So it sent me a random challenge. I want to get it signed. And this is what sort of ties the two together. So it knows if I just replied with, here's my key, right? I could have took that key, I could have replayed that from a different interaction or something like that, okay? So how do I know that this is the key for this particular website? The website gives me a challenge and I have to sign it, okay? So I go back to the secure enclave and I say, you have the secret key, I don't have access to it, so you need to sign this for me. Here's all the information that I want you to sign. And then what Apple will do is it will say, well, wait a minute, we want to make sure you are the user. And so we're going to require a Face ID or a fingerprint check before we allow you to do that, okay? So I did it as a fingerprint on the iPhone, it would be Face ID. So that goes to the user, so the user has to do something biometrically. And then once that's completed, then the enclave is satisfied that it's the user making this request, and then it will go ahead and it will sign the message, okay? So as always, I'm always simplifying the protocols, just trying to show you the bare essence. So like if you look at the format of what's signed, there's going to be a whole bunch of stuff there, but the key pieces are the challenge message that you received, the relay and party, which is the server, so server.com, and then the ID for the credential, which I forgot to mention, but when the enclave creates a key, it also creates like an identifier for that credential. It's just a unique identifier. It will give it back to the user. So here I should maybe go back with the public key and the credential ID. And the reason it does that is you might have multiple users on the same computer. And so what it wants to do is, it's not enough to just know this is the key for Amazon. That assumes that there's only one key for Amazon in this secure enclave, but that's not necessarily the case. So multiple people might use the computer, or one person might use the computer but have multiple accounts. And so what it needs to do is it needs to uniquely identify what it is, okay? So it will sign all of this information, and then this gets sent to the server. So there's the public key, there's the signature, and there's the credential ID. And what the website will do is it will have a database now and it will say, okay, Alice is a user, this is the public key she uses, and this is the credential ID that she's using as well. Okay. All right, questions so far? Okay.
So they're using the public key as a password?
Yeah, they're using it as a way of authenticating who Alice is.
But isn't the public key known to everyone?
Yeah, so far, just to be clear, all we've done is registered an account. It's like we signed up for the account.
Yeah.
So I haven't actually logged in yet.
Just to sign up for the account, so they're using their fingerprint or some type of like mode of authentication biometric to actually log in with and the public key is stored when they actually do that?
Sort of. So the fingerprint is actually just between the user and her device.
Okay.
So like think of my phone. So the fingerprint has nothing to do, say I'm registering for Amazon.
Yeah.
It doesn't see my fingerprint. It doesn't know that I use the fingerprint. It doesn't know anything about that. That's like completely hidden from it. It's just that my phone, before it starts signing things, it wants to make sure that I'm me. And that's Apple's decision. So Apple decided that they were going to do it that way.
Apple is the only company that does this, right?
No. So I guess Android does it, and I think Windows does as well. Yeah.
But it's incorporated in the hardware, right?
Yeah. So in Apple's case, it's in the hardware. It may be the case that, for example, other companies don't use hardware
Is it also
for it.
like the same thing as when we log into like a bank account and we use a fingerprint and like a biometric?
So it depends. So you might use a fingerprint for one of two reasons. One is you might have a password manager.
Yeah.
Password manager knows your password,
Yeah.
but you have to use a fingerprint to unlock the password manager.
Yeah.
So like, and in that case, your passwords would get synced around. And then with secure keys, it's different. And you won't necessarily know, like they both, from a user experience, they both feel very similar, right? Like you try to log into the website, your operating system steps in and says, I can help you, give me a fingerprint. You give it a fingerprint and then boom, you're logged in. You don't really know whether under the hood, if it's a password or not. But on Apple, it does look a little different. So like there will or won't be a password field. And if you read the message itself, it will be like, do you want to use a password or do you want to use a secure key? Like you know, the user experience is different, but if you're not paying attention to it, it feels very much the same.
So it's okay.
Yeah.
Related to this question, when we try to log into Concordia website,
Yeah.
it pops up a number to authenticate the Microsoft Office Teams Office.
Yeah.
When I enter the number into that generator,
Yeah.
that it also authenticates my Face ID.
Yeah.
So how does the structure work in that way? Like the application is authenticating me, and through that authentication, the application is authenticating the number that I'm inserting, then it's getting the approval, then I can log into this Concordia website.
Okay. So let's back up. Okay, so this is Microsoft Authenticator. It's a third way of doing things, first of all, to be clear. So it's, so far, well, we have normal passwords. So let's say there's 4 ways of authenticating. We have normal passwords, right? We have passkeys. What Microsoft Authenticator is not doing passkeys, it's doing something different. There's the idea of a password manager, right? And then there's Microsoft Authenticator, which is technically 2-factor authentication. Okay, so the best way to understand what it's doing is to start from how it started, because it kind of like evolved into what it is, right? So the way it started was you would get an SMS message with a number, you would copy that number into the page itself, okay? Then people said, well, people's phone numbers are getting stolen. It's hard, these SMS messages, we're losing track of them. So why don't we put an app on the phone and it will display a code. It's the same thing. It's just you open the app says this is the code, and now you copy it into the thing, right? So that was kind of like generation 2. Then someone said, oh, we don't even need, we don't really need to do that copying the code over. We could just open the app and the app could kind of talk to the site that we're logging into, and we could just sort of cut that step out. So you basically just open the app, click on it, like click OK or something like that, and then it would log you in. Then there was also a problem with the apps, which is people don't like two-factor authentication, right? They want to avoid it. They don't want to carry their phone around and things like that. And so this was more like in a corporate environment or something like that. But what would happen is people would get like a whole bunch of phones and they would turn them so they're always on, and they would have a video camera and it would just point at the phones. So if you need to log in, you would just do the two-factor, then you would check the video feed, you would see what the number is, and then you would type the number in, right? And so you didn't actually have possession of the phone. So then to combat that, what Microsoft did is they said, no, we're going to give you a code when you log in, and you have to type that into the authenticator. So you can't just have it displaying the code. So that's where that came from. And then Microsoft itself, on the Authenticator app, they're worried that someone will just steal your phone and open it. So that's why it does the Face ID as well. Yeah. And so I think it's absolutely crazy that when I go to Concordia, first off, I disabled all that. But if I was going to use that flow, I would go to Concordia. I'd say, okay, here's my username. Then it'd be like, what's your password? I put my password in. So that's like authentication check 1. Then it would be like, okay, here's this code. Go over to Microsoft Authenticator. Then to get into the app, I would have a Face ID. So that's like a second check. Then I would type it in. And then it like Face IDs me again, like once to like accept the code and a second time to just kind of open the app up. And so it's like I've authenticated like 4 times by the time I log in, right? It's crazy, right? But anyways, I understand like why it's that way, but at the same time, yeah. And by the way, if you don't like it, you can get rid of it. You can't go back to single factor authentication, but you can use other forms of two-factor authentication that are much smoother, right? So like, for example, Apple has built-in authentication. I'll try and show you what it looks like.
I know Amazon has this OTP number that they send to your as an SMS, right? Is that the same concept?
That would be just second factor authentication, I think. So like here, I have a username password, so I just put my password in, but my computer remembers it, so I just use a Touch ID. Then it wants a second factor verification code. My computer knows it, so I just Touch ID again, and then I'm in. And so there's no like opening Microsoft and all this like kind of garbage. But so Concordia does not support passkey, but passkey could be an alternative to this. Yeah, if they did support it. Yeah. And then Microsoft Authenticator itself supports passkey. So you could go into your Concordia account and then set up a passkey for Microsoft Authenticator, but it is disallowed. So I did try to play with that to see. But in any case, yeah, it's this whole authentication thing's a bit of a mess, I would say.
So one of the things that you mentioned was they could store the password in plain text.
Yeah.
Playing around on that thing. So if let's say I'm able to see Alice's phone, which has all the passwords stored in plain text, then I would be able to basically log into Alice's all the accounts that are stored.
Yeah. So if you have a password manager, the password manager stores everything in plain text, which some of them did, the earlier generation ones, then yeah, if you steal that user's device, you steal all their passwords. Assuming that the operating system isn't encrypting everything for that user, right? In which case you might need but if you steal the computer when it's logged in or something like that, then you would get that information.
But I'm guessing because to counter this, they are hashing it as well.
So they may do that as well, but it's actually what they do is they wrap it in a master password. So if you steal it, now again, if you steal it unlocked, so like the password manager is unlocked, then you could still have that sort of attack, right? And you could set it up where like every time I put a password in, I have to explicitly unlock it. which I believe is what Apple does on the phone, because it's usually pretty easy. It's just a Face ID check. So by the time you press the button, you do it. And same here. You saw I had to put my fingerprint in. And so I don't think that actually unlocks it completely. I think it unlocks that one password for that one website, puts it in, and then it goes off, kind of thing. Yeah. But yeah, there would be a split second there where if you sold my laptop, you could get that password. But yeah, everything is wrapped. Yeah, so if you seal it, it doesn't matter. Okay. All right, so back to this. So this is the website's now set up. We have Alice. She has a bunch of public keys. She maybe has different credential IDs because she has different devices. And so the website might have multiple public keys for her. Okay. All right, so let's move on to login. So it's going to be the same parties. I'm just going to copy this so it's easier to remember where they all are.
So the first step is just signing up, right?
Yeah, exactly. Yeah. So we've only signed up. We haven't logged in yet. Okay, so what will happen is Alice will go over to the server, I guess through her browser, but I'll just draw it all the way from her. And she'll say, here's my username. And I want to use a passkey. Okay. Then what the server will do is it will say, okay, and for username, I'll write username equals Alice. Just this will make more sense. And here she's not sending a passkey. It's not something she sends. It's just like I want to use. I want to use a passkey instead of a password.
It's like a permission.
No, it's just how you want to log in. Like it's just so that the server knows that you want to use a passkey instead of something else. I'll just show it to you. So I'll click sign in. Then I will type in my email. And then there's two things that happen. So Apple automatically, we're going to see why, but it knows that there's a passkey for this website, so it just asked me right away. But if I didn't, you'll see here there's sign in. I can put my password in and sign in, or I can click sign in with a passkey. So if I click here, then it's still going to give me the same kind of thing. I sign in and then I'm signed in. Okay, so you'll say I want to sign in with a passkey, basically, yeah. Okay, so how did Apple know immediately that I wanted to, or that it had a passkey for this website? So what the server will do is it will send back a list. It will go look up. It will say, okay, I know who Alice is. I've seen her before. She's a user. I have 3 credential IDs for her. Okay. I don't know. Is she on her phone, her laptop, her work computer? I don't know. That's not my job. I'm Amazon. I don't have to worry about what that device is. So what I'm going to do is I'm going to send these 3 credential IDs and say, these are the 3 IDs I have for you. And then the browser can try and figure out if one of these is something that it knows or not. Okay, and then assuming that I'm going to be able to log in, I'm going to send a challenge value as well, which will operate kind of like the previous one. It's something that I'm going to use to sign in. Okay, then what the browser will do is it will go to the secure enclave, and it will say, okay, I want to do a passkey. First off, I want to know whether any of these are valid. So what the secure enclave will do is it will go in its like database, right? And it will say, oh yeah, I have this credential ID. It's for this relaying party. I know what this one is. Okay. So we'll assume that that's like cred ID 1 in the list. Then it will say, okay, I recognize this cred ID 1. Okay. Now, technically, because there could be multiple users on this computer and there's different servers and things like that, we should also send here like Alice and probably the relaying party as well, even though every key and cred ID is going to be unique. But we'll send that information to it, and it will say, okay, cred ID 1, that's the one that I have a passkey for. Okay, so then it will say, okay, I want to use cred ID 1. So here's the challenge value. I want to do cred ID 1. Here's the challenge. It's Alice. It's for Amazon, which is the relaying party. Can you please sign this? Okay. Then the secure enclave says, okay, I'm going to sign this for you, but before I do, I just want to make sure Alice is Alice. It's not like a device that was stolen. So I'm going to go and ask Alice again for her fingerprint or Face ID. And then I'll get the fingerprint. And then I'm going to assume that it matches. If it doesn't, I'll just stop the process. That's fine. And if it matches, then what I'll do is I'll send back a signature on this information. So I'll have the challenge, I'll have the cred ID, I'll have the fact that it's Alice, I'll have the relaying party, and like I said, there'll be a bunch of other stuff as well that gets sent, but that's basically the essence. I'll call this the signature, and then I'll send that off to Amazon. Okay, and then the server will go into its own database, and it will say, okay, I have the public key for Alice. I know it's Alice that's logging in. I know the PK that matches this cred ID. Okay, so the server, this is, it pulls this out of the database. And then what it will do is it will try and verify the signature. So verify this signature under PK with all of these, with the message value. So the challenge, the cred ID, Alice, RP. I'll just put this in brackets. So this is the message that was signed. And it will make sure that that verifies that it's true. Okay, so that proves that the person possessed the secret key associated with this public key in order to generate the signature over all of these values. Okay, so that was Alice or some device that Alice controls in order to do that. Okay, then it will log her in. When it logs in, it just will do. Then it's the same as logging as normally. So we didn't really talk about cookies, but what it will do is it will set a cookie.
So when it does the fingerprint, it's just a biometric, right? So does it, like, this is what I'm trying to understand. Like, what is it? Does it say the cred ID comes from the fingerprint?
No.
Or the fingerprint is just to see that it matches and then it goes to the next level.
Well, let me explain it. So you have this secure chip, and it has a secret key in it, and you can ask it to sign things for you, and it will go and it will sign things with the key that's inside of it. Okay, but only the user should be allowed to ask for signatures here. So let's say I steal your phone. I could go to it and say, I want you to sign this thing,
Okay.
right? And so what the phone is doing is it's checking that the user is the user before it lets it sign it, basically. Yeah. So the enclave is saying, I will only sign it if I quickly check your fingerprint. And so the enclave is actually the one that checks your fingerprint. It gets the fingerprint value and it checks it like within the enclave itself.
Yeah.
And if it matches, then it issues the signature.
Oh, I see. Okay.
Does that make sense?
Very clear from here that the secure enclave is checking the user is authentic or not.
Yeah, so they're checking that the
Actual user, like is it Alice or not? Like that.
so it's not checking. It's sort of complicated. Okay, it doesn't know anything about Alice at all, and it doesn't know anything about who Alice said she was to Amazon. It doesn't know about that. It doesn't care about it. Okay, but what it's basically checking is any person who picks up the phone can register a public key. Yeah. Okay, so if I steal your phone or something like that, I can register the key. I have to show a fingerprint in order to register it. And what I'm really just checking here is that the same user, the same human user that did the registration is the user that's now coming back asking to log in. So I don't know that it's Alice. I don't know that it's Apple would know it's the user that's associated with Alice's iCloud account, which is Apple's account. So Apple kind of knows who Alice is, but it doesn't know anything about who Alice is saying to Amazon, right? So in other words, if I go to Amazon and say, hey, I'm Bob, can I set up a pass key? Apple's not going to be like, oh, no, you can't do that because you're not Bob, right? It just says, that's fine, I'll store a pass key for you. And then as long as I'm the same user that's coming back each time that I want to log in, then it will keep signing messages and logging in. Yeah? So sometimes we distinguish in cryptography between message authentications and what we call message recognition. Okay, so there's some protocols where it's like, I know who you are because you signed it. And there's other protocols where I don't know who you are, I just know you're the same person I talked to before. Yeah, so it's like the first time we talk, I give you some value, and then later I can talk to you again and I can prove to you that I was that same person. But I actually don't know who you are beyond that.
Because
Yeah.
the session ID that's saved in the cookie, right?
So this is just a higher level thing, not related to cookies themselves, but cookies also are a form of recognition. So I can set a cookie, you'll keep sending it back to me. I don't know who you are, I just know you're the same user that's coming back later as well. Yeah.
In terms of the point, cookie has a time, like the.
Yeah, it has an expiration. Yeah.
Exactly. So it's not gonna hold the whole scenario for a long period of time, right?
Yeah. So usually cookies, they're usually good for a year or something like that. It depends. If it's like a session ID, it might be shorter, or it might be like when you close your browser, it goes away. There's different ways of doing expirations, but the cookies for like tracking users are usually quite long, like long durations of time. But it's totally up to the server, so the server controls the expiration. The client also has control over it. Like you can go in and delete your cookies whenever you want. So you have control, but the server is the one that sets what the expiration is. Yeah. Okay, so the server will set a cookie, it will assign you a session ID, and then every time you go back, you'll show that session ID. And as long as you keep showing it, then the server is happy that you are who you are, and it's not going to ask you to re-authenticate. Okay, questions about passkeys so far? Okay, so let's just look at a couple potential attacks and just make sure that these attacks aren't possible, just to understand it. Okay, let's start with phishing. Okay, so Alice is tricked into visiting Google with 3O's.com. It looks like Google, but isn't. Okay, so in a normal password-based system, so she's using a password. If she's tricked, she'll put her password in if she wants to log in. Okay, so she'll give password. And even though passwords are hashed and all that stuff, you have to send it in clear text in order for the website to hash it. Okay, so she'll give the password, and then the site can steal it. So the site will see it. Let's say we use a passkey instead. Okay, what happens?
Does it reject the pass, like downgrade it because they want to actually like take out a layer of protection, so they would say, okay, you can only log in with password or OTP.
Okay, but why would it reject it?
Because it's another layer of protection, so
It looks for the IP address, and if the IP address on the passkey is not matching for the google.com.
Okay, so that's a good suggestion. IPs don't work because Google could have lots of IP addresses. Yeah, but what doesn't change? Like every time I go to Google, I might get a different IP address because it's doing load balancing. But what's the same across all those interactions with Google? Is the URL or the domain itself. So I'm always going to google.com. Does the domain show up anywhere in this protocol?
Yeah.
Sorry? Yeah. So I didn't write it out. I wrote it out the first time, but I didn't keep writing it out. But I'll write it out here just so it's clearer. Okay. So when the browser goes to the secure enclave and says, I have all these credential IDs, for username Alice and rpserver.com, do you have any passkeys for that site? The enclave will say, no, sorry, I don't have one for Google with 3 O's. Okay, I might have one for Google with 2 O's, but it doesn't match. It's not the same domain. Okay, so I don't even know what that website is. Okay, so with passkeys, the RP doesn't
So how do
match.
you trick someone to go into that site? You just send them a link with
Yeah,
that
yeah.
URL?
Yeah, so it could be like a text or email or a bogus result, an ad. I don't know.
Okay.
Yeah, so we won't worry about how that happens. Just assume that it happens. Yeah, so the RP doesn't match. Enclave won't sign the challenge from Google with 3 O's. Okay, and if let's say you happen, this is kind of a dumb scenario, but let's say that you happen to have a secure key for Google and you had a secure key also for Google with 3 O's, then it would sign it. But it would sign it for the key for Google with 3 O's, and that's useless. You can't use it to log. What you want to do is you want to log into Alice's account on Google with 2 O's, right? And so you can go to Google with 2 O's, say I'm Alice. It will send a challenge to you. Then you could forward that challenge to Alice. But the problem is Alice won't sign it. She won't sign it with the Google key. Okay. So
When he logs into Google with 3 O's, is it when he puts in a username and password, it's just so that he could get those credentials on his side, right? Like
exactly, yes, yeah. That's the purpose of trying to steal it. And then once you have the password, then you can log into Google yourself.
Because the guy thinks he's logging into Google normally, and then he just puts in his regular username and password, and then the guy sort of has a keylogger that can do it, right?
Yeah, so not with the keylogger, but yes, it would store your password, and then you could turn around. If you operated the phishing site, you could turn around and log in to Alice. Now you know Alice's password and her username, so you could turn around and log into Google. Yeah. Yeah. Okay. We can think about replay attacks. So this is something that we usually always consider. So let's say there's an adversary in the middle, and Mallory observes Alice log into Amazon. So she stores all the packages and all the signatures and everything that goes back and forth. Okay. Then let's say Mallory goes to Amazon, says, I'm Alice. And use passkey. Okay. Then Amazon will, I'll just say vaguely, it will run the protocol. So it will start doing all the steps that we had. And then every time Alice has to send something back, what Mallory does is she just replays what she saw from the first time. Okay. So Amazon will run the protocol, and Mallory will replay Alice's side. Okay. Is this attack going to work? And why not? So in the, you mean because of the fingerprint?
Yeah.
So in this case, what I'm going to do is I saw this go across the network. So I'm the adversary. I'm over here on the network. Yeah. So I see, first off, I can simulate this first message. This first message I see. Yeah. Then this message goes from the server. And then what I do is I replay this message. So this message is after all of the fingerprint checking and things like that have happened. Okay. So the reason why this doesn't work is the second time I log in, Amazon's going to choose a new fresh challenge value. Okay. And if it's a challenge value, I don't know what it is, right? And then here I have a signature, but the signature is on the first challenge value. Okay. Or sorry, here. It's on the challenge value from the first time that we logged in. So if the challenge changes, then the signature has to change as well. It has to sign the new challenge. Okay, so that's why this won't work. So yeah, I can only replay a signature on the old challenge value, not on the new challenge value itself. And then the final attack we can think about is a server breach. So Mallory steals all data from server. So in classical passwords, that's where I get everyone's passwords, and that's why we're hashing and salting and things like that. I still get that, and I can still break it with exhaustive search if it's a password that I can guess ultimately. But this sort of slows me down. Okay, here this is what I'm going to get. I'm going to get Alice has 3 passkeys. There's 3 public keys, and there's some credential IDs that are associated with that. Does that help me in any way impersonate Alice? So I have the username, that's not enough, right? I have the public key. The credential ID is just an identifier just so that both parties can track things. It's just kind of like a name. It's not a secret or anything like that. So it's not going to help you. So the question is, if I steal your public key, does that help me?
No.
And why not?
It can be encrypted, but it cannot be decrypted because you still don't have the private key to.
Okay. So if I have the public key, that's fine, but I can't sign anything because I don't have the secret key that goes along with the public key. Okay. So in order, notice that the last step when I prove that I'm Alice, it's based on a signature. I need to sign something, right? And so I'll just write SK in here to emphasize that I'm signing with the secret key. The secret key is the secret key that's here, right? And so where is the secret key sitting in this diagram? It's going to be sitting in the secure enclave, okay? So if I can't get into the enclave, I can't get the secret key. If I can't get the secret key, I can't sign anything, okay? And public keys, as the name implies, public. They're meant to be public, right? They're not a secret. You can share your public key. You can put it on your website, whatever. It's something that identifies you, okay? So there's nothing to steal. So this is the main benefit. This is why people want to use passkeys, right? Is because it's going to get rid of like people stealing your password and password breaches and things like that, okay? And then this is also nice to have as well. Password managers also have this. So if you use a password manager, you save a password for a particular website. If you go to a different website, your password manager is going to say, well, I don't know what website that is. I don't have a password saved for it. So you can get this from a password manager, but you can't get this. And then replay attacks is just like something you always have to have for every protocol. It's just like a basic security property. Okay, any questions about this before we move on? Okay, so if I steal the private key from the enclave somehow, what I can do is I can log in as you anytime I want. So I'll go to the website and I'll log in. All of this traffic, I think I noted it, but maybe I didn't, so I'll just note it here again. All of this traffic we assume is over HTTPS. Yeah, so these keys have nothing to do with the HTTPS keys itself. Yeah, so it's not going to let anyone break HTTPS anyways. And if you steal the key that's used for logging in, it doesn't help you with that type of stuff. Yeah. Yeah, so that's something different. Okay, other questions? Okay, I'm moving on. Okay, so what we just talked about we call authentication. Or authn. Now what I want to do is I want to talk about authorization. So authentication is sort of like who you are, and authorization is what you're allowed to do. And sometimes we abbreviate it to authz. Okay. And so here we talked about passkeys. Here I'm going to talk about something called OAuth, or open authentication. And then I'm also going to talk about the idea of single sign-on. So single sign-on is that you can log into any website using, say, Google as your identity provider. So you have an account with Google, and then you don't have to create an account on every website you go to. But when you want to log into that website, you have to go back to Google. You have to log into Google, and then it does. Okay, so we call that OpenID. or OpenID Connect is the protocol, ODIC. And you might think that this sounds closer to passkeys than to OAuth, but as I mentioned earlier, it actually is very similar to OAuth. So all the stuff you have to do in OAuth, you basically have to do with ODIC. It just kind of changes like at one little point in the protocol itself. So once we understand this protocol, understanding this protocol isn't so difficult. Okay, OAuth is not really a crypto protocol. There is a tiny, tiny bit of cryptography that's used, but it's more of an architectural protocol where just these parties are talking to these parties and this is what they know about each other and this is what they're exchanging type of thing, okay? So it's a little different than a lot of the protocols that we've looked at in the sense that it's not really a crypto heavy protocol, but anyways. Okay, so I'm going to set up a scenario that looks like this. This will be our sort of working example. So we have a user, Alice, and we're going to have two different websites, okay? We're going to have a website called, I'll use a real example of a website that I use called TripIt, and it's like a travel app. And so the way it works is, let's say I book a hotel, I get this email, from Sheridan saying, here's all my details of my account. What I do is I just forward that. I forward it to plans@tripit.com. And then TripIt grabs that email, it parses it, it figures out, oh, this is a hotel, these are the dates, this is the address, this is the booking code, and then it puts it in the app. So I have this like calendar where now I have like, the dates that I'm traveling and which hotel I'm in. And then I can do that for all of my, if I book a flight, I'll forward it and things like that. And it will realize that the flight dates overlap with the hotel and they're in the same city. And so it will bundle it together as one trip. And so I'll have a list of my trips and then I click on it and it'll have everything there, my flight, my hotel, my car rental, like whatever I need, okay? Now, another thing you can do with TripIt is I can say, instead of me sending the email to you, why don't you just scan my Gmail constantly? And if you see anything that looks like a booking email, then just throw it into my travel itinerary, okay? But in order to do that, I need to give permission to TripIt to access my email, okay? So that's what the problem is that we're solving, okay? Another thing is I might say, TripIt, I want you to add all this travel stuff to my calendar. I have Google Calendar. I want you to add it to it. It could give you a file and then you could drag the file over, but instead I could just authorize it so that even if my plans change on TripIt, then my calendar stays in sync as well, okay? There's different ways of doing that. There's probably more elegant ways than just allowing TripIt to write into my calendar. For example, it could give me a calendar feed and then I could add that to my calendar as a separate kind of feed. So anyways, this is sort of a contrived example, but that might be another reason why I would want to authorize TripIt to have access to my Google account. Okay, so I have Google here, and I have things like Gmail, and I have Calendar. Okay, I'm going to assume that I have an account with TripIt. I also have an account with Google. Okay, later, next class, when we talk about here, I'll talk about, well, what if I just log into TripIt with my Google account? But for now, we'll just assume that I have two separate accounts, okay? Those accounts could be passkeys, whatever. We'll see at what point you use the fact that there's an account here later. And what I want to do is I want to authorize and I'm going to have a set of things that I want to authorize. So I might authorize like read Gmail, read write for a calendar. Okay, and there could be different scopes here. Like that's up to Google. So Google's going to decide what they're going to, how fine they want the permissions to be on what you can do with each of their services. Yeah. So that's, Google can decide whatever it wants. But anyways, at a certain point, Google wants to know when TripIt shows up and says, hey, I want to access Jeremy's Gmail, right? Google has to know that I'm okay with that. I'm good with that kind of thing, okay? So we need some sort of protocol. It's going to be a three-way protocol between me, TripIt, and Google, and we're going to get this whole thing set up, yeah? So anyway, so that's what OAuth is. It's a protocol. It's one of a bunch of different ways of doing it, but it's the main one that's used on the web, yeah.
It's going to use your Google credentials to log into TripIt?
So it's not going to do that. We'll consider that case later, but for now, just assume I have one account on TripIt and I have another account on Google, yeah? And it doesn't matter if I'm presenting myself as the same person or not. They don't care.
Okay.
But TripIt wants to access my Google stuff, yeah? And so I need to tell Google who I am on TripIt so that when TripIt comes asking for it, it says that I authorized it. Does that make sense?
Yeah.
Yeah. Okay. Now I'm just going to put some names of stuff. Now let's say that this does happen, this authorization happens. How does it actually read my Gmail? What Google will do is it will have like a server for Gmail, and it will have what's called an API. And what happens is TripIt will be able to access Gmail through the API. And usually, in order to access the API, you have to have a secret token. So when I show up, I'll say, here's my secret token. And then Google will say, okay, I know that that token is for Jeremy's Gmail account, so I'll give you that access to the stuff itself. Okay, so okay, so I'm going to call this the application. This is called the ID provider. And in this case, it's also going to be called the authorization server. So it's technically only the ID provider when we start doing this protocol. So for now, later we'll call it this. Next class, we'll call it an ID provider. For now, we'll just call it the authorization server. And then this is, we call the resource server. So it's the server where you're getting the actual content of the Gmail or the calendar app itself. Okay, I'll try not to use these acronyms anyways, but just in case they show up, that's what they all mean. Okay, so I'm going to sketch in an attempt at a protocol. That's going to kind of get the essence of the protocol, but then there's going to be some problems with it. And then what we'll do is we'll fix the problems one by one, and then we'll do the protocol again from start to finish with all the fixes in place. And that will be the actual final protocol. Okay. So the first step is Alice tells TripIt to access. I'll just keep it to her. I'll put both email, calendar. Okay. Then what TripIt does is TripIt forwards Alice to Google. with the request. The request to have TripIt access her email and calendar. So now Alice is talking to Google. Google will show a consent screen. So it'll say, do you authorize this app to access your email? And there'll be a bunch of things like that. So it will ask Alice for permission. We'll see that Alice approves. And then what Google needs to do is it needs to pass a token back to TripIt in order for TripIt to be able to access the services itself. Okay, how's it going to do it? So at the first attempt, what I'm going to do is I'm going to say Google forwards Alice to TripIt. With an access token. Okay, so it will reply to Alice and say, I want you to go to this URL, tripit.com, access token equals ABC. And then when Alice's browser will go there, and then it effectively tells ABC to TripIt. Okay, then what happens, so then Alice can go offline, so we don't need Alice anymore. And then what happens is TripIt will use token with Gmail, Google Calendar. Okay, so TripIt will, after Alice goes offline, TripIt will just every hour or every day, it will ping Gmail and say, is there any new emails? And it will go through them and see whether any of them look like booking emails or not. Okay. But Alice is no longer involved, okay? So I'm authorizing TripIt to do this. Even if I'm offline, TripIt is still checking my email, it's monitoring it, it's still adding stuff to my calendar, okay? And so the way that could work is with a token. Usually you get 2 tokens, so one's like, usually the tokens are short-lived, so they might only live a day or something like that. But then you'll get a second token called a refresh token, and you could send it to get a new token, essentially. So you once a day I send the refresh token, I get a new token, and then I use that token throughout the day. When it expires, then I send the refresh token again, and I get another token. And then if someone steals that token in the middle, then they only get access for a day. But if they steal the refresh token, then you're done. Yeah.
So the thing is, can you please go up?
Yep.
So when Alice is offline,
Yep.
TripIt does the functionalities on behalf of Alice.
Yeah,
Right?
yeah.
But whenever, like, getting the information from Google to TripIt, what does it do? Updates the calendar, right? So in order to access that calendar, Alice needs to sign into the TripIt, or TripIt sends back to Alice with some stuff like a message, or how does it sense it? In order to access that TripIt, like get that information, Alice needs to sign into TripIt, but instead she can directly get it from Google. So why the use of TripIt instead using the Google directly?
So in this case, it's not so much that I'm going to look at my calendar through TripIt. It's that that TripIt now has write permission to my calendar. Like it can write events to my calendar. So let's say that TripIt, like say I forward an email to TripIt, and it's like, okay, now I know he's in a hotel from these dates. Then it can go directly to Google without me involved, and it can add that event to my calendar. Does that make sense? If it doesn't, ask, because you need to have the right mental model of what's happening here.
So the TripIt is booking a trip. It's like an Expedia site?
It's different. So it's just a site that keeps track of your trips.
So you don't actually book the trip on that site?
Yeah, you don't book it on it.
You just sort of schedule it on that site?
Yeah, it's like a friendly scheduling kind of website
You say
kind of
like
thing.
I'm going to like New York on a specific day at a specific time, and then it adds it to the Google Calendar.
Yeah, exactly. So think of it that way. Except for you don't have to tell it anything. It will just see, like, say someone, I don't know, I get a flight booked to New York,
Yeah.
and so I get that Air Canada email.
Yeah.
TripIt, because it has access to my email, it will say, oh, I see an Air Canada flight for you.
Okay.
I'm going to go ahead and create a trip in it, and I'll add it to your Google Calendar kind of thing. But all of this happens automatically. I don't have to talk to TripIt. I don't even have to be like logged into TripIt. It just happens.
Okay.
Yeah.
So it's just an app just to like keep track of your trips, and then it's gonna save it to the Google Calendar.
Exactly, yeah. And it's going to know about new trips because it's watching my email. Yeah, so it's reading my email and it's writing to my calendar, effectively.
Okay.
Yeah. And none of this matters. Like, it's not important to understand TripIt per se, but it's just, yeah, to think about like one website getting access to the resources of another website. But yeah.
So the difference in between passkey and OAuth is almost similar to PGP and Signal, right?
Not exactly. So passkeys and OAuth solve different problems.
And
Yeah. So here, I assumed Alice is already logged in. So maybe she used a passkey to log in, and maybe she used a passkey to log into Google. And so, yeah, so passkeys will show up inside of OAuth. There'll be a certain step where if the user's not logged in, you'll ask them to log in.
What I mean is when you were talking about the tokens themselves.
Yeah.
So if we steal one token, we only have access to one day only. We won't have access when the tokens get refreshed. We will lose the access at that point.
Correct, yeah.
So kind of behaving like Signal in that way.
Yeah, so I guess, yeah, so in Signal, like there is the, if you're able to steal a key, then yeah, there's a recovery mechanism where you can recover. So yeah, at an analogy level, that's right, yeah. Okay, other questions about what's going on here? Okay. All right, so this is the basic setup. So this is the protocol that we'll sketch in. But there's a couple things that we need to do to make sure, like, we can't replay. These tokens are scoped to the right thing. We'll think a bit about how Google passes the token to Alice. Alice passes it to TripIt. That means Alice has the token at some point in her possession, right? That's not like the worst thing in the world, but maybe Alice has like antivirus software that logs every URL she visited. That access token will be part of that URL. And so now it's going to be in that log kind of thing. And so there's a bunch of reasons why this could maybe go wrong. So anyways, we're going to fix all of these issues next, but it's a good time for a break. So why don't we take a break and then we'll come back and look at it.
It seems to go together.
Okay. So there was a couple people during the break asked the same question, which was good, which is sort of how do you revoke this? So once TripIt, I authorize it to access my Google services. How do I get rid of it? I mentioned that there is a short-lived token, but then there's this refresh token that you can use. So there's two ways. One is I can go to TripIt and just say stop accessing it. And if I trust the site, it will stop. I mean, I trust it anyways by letting it have access to my Gmail, but then it can, it might honor that and just stop accessing and delete the token. Or what I really want to do is, if I want to be careful, is I want to go to Google. And so Google will show you every site that you've authorized with OAuth, and then you can go in and you can revoke it if you want. So just to show you what that looks like. So I'm logged into my Google account here. I have security and sign in. You can see here I have passkey and all this stuff set up. And then down here it has your connection to third parties and services. So this is all the stuff that I've set up with OAuth. So there's sign in with Google, and then there's the OAuth stuff. Sign in with Google, I said we'll talk about next class. So that will be the OIDC, but it's very, very similar. It's actually part of OAuth. It's just It's sort of a layer that's thrown in at a certain step in the protocol. So it shows it side by side. But you can see there's a bunch of apps here that I have configured. So if I'm like, I don't know, this Chromecast, like I don't even remember what that is, then I could delete everything to it. And now I'm not connected to Chromecast anymore. Yeah. And so I don't know, maybe these are TVs, like I have Apple TV.
This
So
only works in Chrome?
sorry, I'm on Google's website.
Google website?
Yeah. So anyway, yeah, and then it shows there's different kinds of permissions. So like for Google Classroom, I have this set up. For Google Calendar, these are the things I have access to. For Google Drive, these are the things. So yeah. So like for example, Slack is something I use for communicating with students, and so Google Drive is kind of plugged into it. So if someone creates a new doc or they edit something on Google Doc, then it posts a message on Slack. That's because Slack is able to monitor Google. Yeah. Okay, so the travel thing, I think, hopefully it didn't confuse you too much. This is just like an example. It has nothing to do with travel at all. Just think of it as like you're authorizing people to access your Google account for whatever purpose you want. Okay. Okay, so this is the attempt. And then what we'll do is I'm going to call it adjustments. So we'll try to see that if there's any problems with it and how we can adjust them. And then we'll throw together everything into a protocol itself. Okay, so the first thing we want to do is we don't want to give complete access to services. Like, here's my Gmail. You can do anything you want. You can read, you can write emails on my behalf. You want to give like kind of the smallest permission that the thing needs to do its job. So in this case, it's monitoring emails. It doesn't need write permission. It doesn't need the ability to send emails in my name. It just needs the ability to read emails, right? Similarly with the calendar, it can maybe add events to my calendar. Does it need to read everything else that's on my calendar? It doesn't, right? So what I want to do is I want to scope tokens to specific permissions. Here, there's a principle in security, we call it least privilege. Be helpful if I could spell the word privilege. I think that's right. And so least privilege just says give the least amount of privileges that they need. Don't give them more permissions than they need, kind of thing. Okay. Now here, this is really up to Google to support, or whoever the authorization service is. So Google must be set up to allow you to read or not write, or only access the calendar entries that you've added to the calendar, not everyone else's. Okay, so Google can support whatever permissions they want, but the point is OAuth will pass these around. So Google will write down the permissions that they offer. The OAuth will take care of getting the user's permission in order to have these permissions, and then Google will have to support it itself. Okay, expiration. So typically, tokens are short-lived, just in case they get stolen. But there's a refresh token. Allow new tokens. And these new tokens are from Google to TripIt, and they don't involve Alice. Okay, so all right. Now I set up a scenario where like TripIt is checking my email every month, or sorry, not every minute, probably like every 10 minutes or every hour or something like that. And so it never every time the token expires, it immediately refreshes. Okay, that's like one kind of scenario, but there's a lot of scenarios where you might use OAuth where, like today, the service is talking to Google, right? It uses some token, but then it's not going to come back to Google for 6 months or a year. Maybe a year from now it comes back. So for that year in between, it doesn't need an access token. All right, and so instead of having that token last a year, it's a lot safer to just have it last a year. Sorry, last a day. Then the service goes away. It has no token that works. And then a year from now, when it needs a new token, it will send the refresh token, get a new token. And then it will use that for that day. And then same type of thing, okay? So sometimes with these OAuths, there's like, people are just infrequently accessing the server. So instead of having permission, having a valid token lying around at all times, they just, they get the token when they need it, and then it expires quickly. Okay, so yeah. Okay, now let's talk about how to pass the token from Google to TripIt. Okay, so the way I wrote it is Google forwards Alice to TripIt with an access token. Okay, so what does that mean? I'll give you an example. So Alice is at Google. Okay, so she just did the whole permission thing. I give permission in order to do it. Google now wants to send the access token back to TripIt. So what Google will do is forward. So it says, hey, Alice, go over to this URL. And it could look like, all this will always be over HTTPS. Tripit.com. And then it will just put the token there in the URL. Okay. Usually, in order for TripIt to know like this is a token and things like that, it will have some function like callback or something like that, and then there'll be like a token. Let's call it XYZ. In reality, these tokens are going to be long and random, and you can't guess them. But anyways, okay. So we'll just send this token to it. Okay. Then what Alice does is she receives this URL. Her browser receives it. She visits this URL, and so this goes to TripIt, and it says, oh, I want to access this page called callback. And TripIt's like, oh, I know what that is. That's an access token. And so here it is, so I'm going to store that. I know that it was Alice that sent this URL to me, so I'm going to assume that this token belongs to Alice. And whatever Alice was asking to do, this is the token that's going to let me do it. Okay. Now it might be more than one token, like Gmail. There might be a token for Gmail, a different one for Calendar or whatever. But just to keep things simple, we assume that it's one token. Okay. What's the problem with this? So there's no real big problem with it. Everything's over HTTPS. So if there's an adversary in the middle, they're not going to get the token. If Alice has malware on her machine, it's going to be a problem. The malware will get the token. But usually if you have malware, you're already like in big trouble. It could probably steal your Google password when you type it in or whatever. So like generally we don't really worry about malware. But there's something that's sort of in between where there's some kind of services like say antivirus services and things like that. And every URL, they just log it. So they create a log of every URL that you go and visit to, okay? And now we have secret information sitting in the URL, okay? So that gets put into the log. And now if I steal the log from you, like I know you're running a certain antivirus software, and I go in and I just try and steal that file, normally that wouldn't be a big deal because it's just a file of, it's a privacy consideration. It's a file of all the URLs that you visited, but I shouldn't get any sensitive information from it. But now the token's sitting there, and so I get it. And then even worse, what some antiviruses will do is they'll post these URLs online. So they'll say, oh, users went to this website. And by the way, has any other antivirus checked out this URL? Can it tell me whether it's safe or not? Okay. And so I was in a recent talk where someone did a study, a thesis, master's thesis, and they looked at some of these. The name's escaping me, the one that does it, VirusTotal. And so it's one that has all these URLs. So they went through all the URLs looking for tokens like this, any kind of token, but including an OAuth token, and they found lots. So they were just logged. And then they tried to log into the website with the token, and in a lot of cases they were able to log in and then see stuff. But yeah.
Isn't the URL, I don't remember, is the URL inside the secure tunnel?
Yes. So in terms of the secure tunnel, this part is inside of the secure tunnel. So if you're a man in the middle, you won't get this token at all. Yeah.
But not everything.
Exactly. So you do see this. You see tripit.com, and you know it's over HTTPS just because it looks like HTTPS. But yeah, you won't see this here. Yeah. So it would have to be like the user purposely like putting this URL somewhere that they shouldn't. Yeah.
So he's putting the token is directly in the URL?
Yeah.
Okay, but how is he typing that in?
So you're not
He's not typing it in, but when he's logging into trip.com, it's like a REST API that's actually adding it, right?
Yeah. So Google is creating this URL, and then it's just telling Alice's browser go to this URL.
Okay.
Yeah, go load it, and then Alice will do it, and then this information gets sent to tripit.com.
I see.
Yeah, because it's part of the URL.
Okay.
But if it is in the tunnel, then how antivirus like?
So what I meant here is that so let's say that okay. So let me write down what's the issue here. So let's say Alice runs VirusTotal on her computer. Okay, so her computer is outside of the secure tunnel. So the secure tunnel is between her computer. Yeah. So now it's been decrypted. It's on her computer. Yeah. So Alice runs VirusTotal on her computer, and it logs the URL. Then it basically logs the token. Yeah. And if it's a refresh token, then, I mean, that token's good forever, basically. So.
Sounds like something McAfee would do as well.
Sure, yeah. Okay, how do we fix this?
Is this where LLM comes into play, or it's like?
No, not really, yeah.
To hash it?
We could hash it. We could play around with hashing or throw some sort of encryption on it.
Encryption can be good.
But in this case, yeah, we would have to encrypt it under Tripit's key. So Google's going to have to try and figure out the key. So there's maybe a PKI issue there. So I'm not expecting you to guess the answer. It's actually pretty simple, but I'll just draw it in. So what we're going to do is instead of sending the token, I'm going to send a, yeah, go, yeah.
You send the header, so I think you have to pass the token two headers because it's from JSON and then.
Okay, yeah, roughly. So what we're going to do is we're going to send like a ticket to claim the token. So we're going to send a secret value, and then Tripit can take that secret value and go to Google and get the token directly. Okay? So instead of sending the token, we send a token that gets you the token, effectively.
Kind of lock and key.
Yeah, maybe, yeah. So it will look exactly the same. Okay, here we call it an auth key. So I'll write ABC.
But then, let's say if Trippin, if we are able to look at that URL, is it directly available over there, or is it like also encrypted, or?
Okay, so let's keep that question for 1 second. Yeah. So like if this, we're going to assume that this URL is also going to get logged, right? So ABC is going to be sitting there. But for now, let me just complete it. So they forward it. So now TripIt knows that it has this callback ABC. Then what happens is TripIt without Alice. So this doesn't involve Alice at all. It just, in the back end, TripIt will send to Google ABC, and then Google will send back to TripIt XYZ. Okay, I'll call this the access token. Okay, so it will ask for it, and then it will send it back. Okay, now what if this gets logged? Right, it's ABC. Then what you can do is you don't have XYZ. That's what you need. But you could also go to TripIt and say, here's ABC, and then go to Google, and then Google will send you back XYZ. Okay. So what we're going to do is we're going to try and scope this token so that TripIt is the only person that's allowed to ask for it. Okay. So when we get ABC, we'll also check that it's coming from TripIt. And if it's coming from TripIt, then we'll give XYZ. And if it's coming from any other website or any other domain or IP address, then we won't accept it. Okay. Okay, I sort of got ahead of myself. That is one way we can solve it, but actually we're going to solve it a slightly different way. There's a better, more robust way of studying it. Before I talk about it, though, is there any questions so far? Okay. Okay, I'm going to elevate it to its own kind of bullet point here. Okay, so what will happen is TripIt will, we're going to do like a kind of challenge response sort of protocol, or actually it's more of a commit reveal protocol. What TripIt will do is they will choose a random value. We'll call it V. V stands for verifier code. TripIt will send a hash of V to Google when passing the user to Google. So I'm going to draw out the whole protocol so you'll see where it is later, but I'll just say when passing the user to Google. And then I'll just remind you of the attempt that we went here. So TripIt forwards Alice to Google with the request. So this is at that stage. So what it's going to do is it's going to say, here's a hash of a value. Google will ask Alice for permission. Alice will approve it. Then Google is going to send the token back to TripIt, Now what it's going to do is it's going to send a claim for the ticket, not the ticket itself, or a token. It'll send a ticket for the token, but what it's going to do is it's going to do that. That's exactly the same. Then what happens is TripIt comes back and says, I have this ABC value. Okay, I want XYZ. And what Google will say is, hey, earlier you sent me the hash of a value. I want you to send that value itself. So I want you to send me V, and then I'm going to check whether V matches H of V. And if it does, I know you're the same person that was talking to me before. Okay, so somebody else steals ABC, they don't have V to go along with it, so they're not going to be able to claim it. Okay. So later, when TripIt sends ABC to Google, it must also send V. Then Google checks that the hash of V equals the hash of V that it got before. And then assuming that it checks, it will reply with ABC or XYZ with the token. There's a question? Yeah.
The V itself in typing is not like a commitment.
Yeah, so the hash, usually when you hash a value, we call it a commitment. Yeah, so the hash of V is the commitment. V is the message that was committed to. And then here you're opening the commitment or revealing it to V itself. Yeah. Okay, and this whole thing has a fancy name. It's called PKCE. Which stands for Proof Key for Code Exchange. Just in case you see that acronym somewhere. And do I have any other jargon? And this thing, the hash of V, we call a challenge code. I just want to make sure you have the term. So if you're reading about this somewhere else, then and it's talking about challenge codes and authorization servers and things like that, you can kind of map it back to what we're talking about. Okay. Questions about this? Okay, let's keep going. Okay, so what happened is basically the user went to TripIt. TripIt sent the user to Google. Okay, and then Google sent the user back to TripIt. Okay, how does TripIt know that when Google sends, basically when the user comes back to TripIt, how do they know that the token that they're receiving has to do with the token that they were trying to get when they sent the user to TripIt? In other words, the user starts at TripIt, they send the user over to Google, okay? Now imagine for some reason, I don't know why, let's say the user goes to Google and they just close their browser window, okay? Then they go back to TripIt and they say, I want to set this thing up, and TripIt sends them to Google again. They close the browser window, right? And then they go back to TripIt and they ask to get sent again. This time they do the thing at Google, and Google sends them back to TripIt. How does TripIt's like, well, I sent the user there 4 times in a row. Which response is this? Like this, Google is telling me that the user did something, with Google to authorize me, but was it the first request, the second request, the third request, or the fourth request? I don't know. Okay, so what we need to do is we need to bind together when the user sends when TripIt sends the user to Google and the user comes back, we need to bind those two sessions together so we know that they belong to the same session. Okay? And you could imagine there might be like an adversary that kind of does the first step, and then the real user does the first two steps, but then the adversary takes the second step and tries to bind it to their first step or something like that. It's hard to like give the intuition, but there's a bunch of things that you can do where I might replay this step, for a completely different first step or whatever. Okay. So in general, but just it should strike you that like if I send you to someone and you come back to me, I need to know that you're coming back about the thing that I sent you to that person for. Okay. So I want to bind those two things together. Okay. So it's pretty easy to do. All we're going to do is we're going to generate like a kind of label for this connection. So TripIt will generate it, and then it will include it when it passes the user over to Google. Then when Google passes the user back, it will also include it. And then TripIt will look at it and say, okay, these labels are the same. Therefore, they're the same connection. They're bound together. Okay. All right. So is this part of the same session? Okay, so TripIt will generate a nonce, and this is called state. I don't know why, but to me it's sort of a weird name for it, but it's called state at random. TripIt includes state when passing user to Google. And then Google will include state when passing the user back. Okay, the last thing I want to talk about is the token itself. So the whole goal of this protocol is to let TripIt access, say, your Gmail. And the way it does is it sends an API request. And it says, I have this token, and this token gives me permission to read this user's email. Okay, so there's two ways that you can do tokens. So we'll call this the access token for the API. There's what we call a bearer token. A bearer token is like a secret value. If I have the secret value, you give me access. So I just show up, I'm like, here's the secret password, and then you get let in. If someone else steals it, they can show up with the same token and they'll get access. So all I do is I just look at the value of the token and then I get access. So a password is like a bearer token. Anyone who knows it, we don't ask any other questions. A cookie value, a session ID, it's like a bearer token. So we can do the same thing here. So a bearer token is just like if you know the value, you get access. Okay, the other thing we could use is a signed token. And a signed token, there's no actual secret in the token. All it is it's a message that just says TripIt is allowed to access the user's Gmail signed by Google. Okay? And so when you show up with that token, Google looks at it and says, yeah, I signed that message, so it must be true. And then if someone else steals it and they show up with it, it says, well, TripIt's allowed to access it, this person isn't, so the token isn't of any use to them as well. Okay? So this is the kind of token that we prefer. So the idea would be Google signs a token, which is just a message that basically has all the information about what's happening. So it will say, here's the scope. Scope would be like read Gmail, as opposed to read write Gmail or something like that. It would say, okay, this is for Google. It's for the user Alice. The person that's allowed to send it is TripIt. And, it expires tomorrow, April Fool's Day. That's right, April 1st. Okay. And then there's going to be a bunch of other fields in there. There's different ways of formatting it. Very common kind of token type that you may hear of is called JWT. So J is JSON, I think, and T is token. I forget what W is. What? Web. Okay. Yeah. So JSON web token, or is it Java web token?
JSON.
Yeah. Okay. But ultimately, this is just a formatting of how you format the token itself. But anyways. Okay, so if we put these fixes into this protocol, then we'll basically end up with OAuth and how it works. Okay, so let's write out now OAuth, the actual OAuth protocol. All right, so I have the user. I have TripIt. And I have Google. And then later I could have, say, the Gmail API. So it's owned by Google, but it's basically like where do you go and actually get the data itself? Okay. So TripIt I'll call the app. Google I'll call the authorization server, and Gmail I'll call the resource server. And Alice I'll call the user. Okay, so the first thing I do is the user goes to TripIt and they log in. Okay, so this could be where passkeys fits in, or it could be username, password, two-factor authentication, whatever. Okay. All right, so this would be like a back and forth, and that whole protocol back and forth with the fingerprint and all that stuff would happen. So now I'm logged into TripIt. Okay, then what I do is I say, okay, I want, I'm going to grant access to Gmail. Okay, and what TripIt will do is it will send back a redirect and say, okay, that sounds great, but I don't have permission to access Gmail. You have to go ask Google for it itself, okay? And so I'm going to direct you to, let me also note that all of this stuff is over HTTPS. Okay, so no, nothing here is not over HTTPS at this point. So I'll send you to Google / I'm just making up URLs, OAuth, and then I'm going to have a bunch of parameters about this connection itself. Okay, and the parameters are actually something I generated. So let me move this down and just here write down what I need to do. So what TripIt will do is it will choose a random V, and what it's going to do is it's going to set challenge equal to the hash of V. So that was the protocol here, this PKCE. Okay. And the other thing it's going to do is to bind these things together, it's going to create the state as well. Okay. So at random, it will choose a state value as well. Okay. Then it's also going to choose the scope of what it wants to do. So I'm just going to keep it simple. I'll say I want to read Gmail. But it could be read Gmail, write Gmail, read calendar, write calendar, or like whatever that type of stuff is. And if Google approves this, if Alice approves it through Google, I need to get back that token somewhere. So here's where I want to get the token back. So I have a callback URL. And it's going to be https://tripit.com/callback.
So you're basically allowing it to read all your emails.
Yep, exactly. Yep. So that's the permission that's getting set up here. Okay. So I'll redirect to Google. The website TripIt will have to know where Google handles this, so like what the URL is, but that it's something that it would set up with Google ahead of time when it integrates. Okay, and then basically all of these, not the V won't get set, but these values will all get set. Okay, so the challenge, the state, the scope, the callback, all of that stuff gets sent. Okay, and then what the user will do is they get redirected to this URL, so they end up sending this URL to Google. Okay, so Google gets all of this information. Okay, good so far? All right. Now, what Google will do is it will say, the user's logged into TripIt, but they're not necessarily logged into Google. Okay? So Google will say, who are you? That would be the first thing that they say. And so what Alice will do is a login with Google. And the login, again, it could be passkeys or it could be any other protocol. But this is where the stuff we talked about last lecture fits into this overall protocol. Okay, so now the user is logged into Google. Okay, and what Google will do is it will send a permission screen, basically saying, okay, there's this TripIt app, and it's trying to read your Gmail. Do you want to allow that or not? Okay, and so then the user will consent to it, we'll assume that they do. Okay, and then Gmail will say, okay, great. I'm going to create a token that TripIt can use to read your Gmail. Okay, so it creates access token, and it's also going to create the authorization code. Okay, now what Gmail's going to do is it's going to redirect the user back to TripIt. So it's going to say, okay, I'm going to redirect you. You're going back to TripIt. At the URL that I got up here. So I got this callback URL. So I'm going to send you back to this callback URL. Okay. And I'm going to give you the auth code. Well, first off, I'm going to include the state. So you sent the state to me, which was a random value that you chose. I'm going to send the state back to you so that you can connect this connection to this connection. So this is the response for this request. Okay, so in case you have lots of users that are requesting lots of things at Google at the same time, we can track it. And I'm going to send the auth code as well. Okay, then we're done. Alice is done. Okay, everything is good. It's everything is signed. Oh, actually, sorry. I guess Alice has to go to TripIt. Sorry, so Alice has to follow the redirect and go to TripIt and send the URL so that TripIt gets a copy of all this stuff. Okay, so then Alice can go offline. So I'll just sort of draw. Okay, and now what TripIt's going to do is it's going to talk directly to Google. So TripIt is going to say, hey, Google, you gave me this auth code. But what I need is the API code. I need the actual access token. Okay, so I'm going to send you the auth code. You're going to send it back to me. But because I'm worried that someone's going to steal this auth code because this URL gets logged in, I'm also going to send you V. V was the random V here, and I sent hash of V. Okay, and so earlier I sent chow, which is the hash of V, and now I'm sending you V. And what you're going to do is you're going to check whether the hash of V equals challenge value. Okay, and assuming that that's the case, then you'll send me the access token that belongs to this auth code. Okay, then TripIt will go to Gmail. So we'll go all the way over to the Gmail API, and it will make an API call, and it will include the access token. Okay, and then the server will say, okay, that's a valid access token for reading Alice's Gmail, and so I'll send you all her Gmails, or whatever the case is. Okay. And one other thing I forgot to mention is usually, so here we send an access token and we send the refresh token as well. So we have two tokens here. I'll just mention it here as well. And then if this call, either it's like, here's the Gmails, or it's like, oh, that token doesn't work anymore, it's expired, then you'll just reply with the refresh token and get a new access token. Then you'll ask for it and get it. So I won't put that information in, but yeah.
So you said the access token is like probably 1 day long, and refresh token is like 1 year or something?
It's forever, basically, yeah. Until I go into my Google account and I get rid of it. Yeah. So I go in here, otherwise it lasts forever, yeah.
So the connection is established between TripIt and Google. So what happens if I change my password on TripIt or Google?
Nothing happens because right now it's just getting direct access to your account. And so Alice is no longer in the picture. So it doesn't matter. Like if she changes her password or anything like that, TripIt is accessing your email by going directly to the Google API.
Just because the connection is established, no matter if anything happens between passwords or something
Yeah, if anything happens with the passwords or anything like that, it doesn't change. Now, TripIt has direct access to your email straight from the Gmail server. It's almost like TripIt has its own password for your email. It has its own login credentials. So now there's like two people that can access your email. There's you with your password, and there's TripIt, right? But if you change your Gmail password, it doesn't change TripIt's password for your Gmail. And if I change my password to TripIt, it doesn't stop TripIt. TripIt already has access to my email, so it doesn't change anything about the access to the email. Does that make sense? Yeah? Okay.
So it only activates, I'm talking about when Alice is offline. It only activates when you get a new email about your trip then? The trigger would be...
So no, like what happens is TripIt needs to, so there's different ways of setting this up. So the OAuth doesn't care about how it's set up. It basically just says, here's a URL and here's a token, do your thing, kind of thing. Yeah, we should actually probably pass the URL to Gmail maybe as well. But in terms of how TripIt works is, in general, there's two models. There's a pull model and a push model. So the pull model is just I check every 10 minutes or every hour. Yeah. And then if there's new emails, then I get those new emails. A push would be Gmail gets a new email and then it goes over to TripIt and says, hey, I got a new email. So TripIt just sits back and waits for Gmail to tell it. Yeah. So I don't think Gmail offers push like stuff.
As far as I know, I think the best way to put it is that assuming you're Alice has the key to a house, and then TripIt has a key to the garage. So you have access to a part of the house whenever you want, without any trigger, without anything. And if the house key gets changed, the garage key is the same.
But like I was the main was what would be the trigger that like triggers everything to like for the flow to start working again, and that you just answered.
Okay.
But yeah, I agree with you, like kind of the garage door analogy.
Okay, any other questions? Yeah.
We have access tokens and the refresh tokens at the same time? I'm quite confused.
Sure. So the refresh token, think of it as a token that lives forever.
Okay.
It gives you access forever. But to the actual token that you'll send when you want access is the access token. So it's like a temporary token. So basically, the refresh token you store, and then you send it to Google, and Google says, here's an access token. Then you use that access token until you're done or until it expires. Yeah? So if you're done with it, then you delete it, but you keep your refresh token. You go offline, and then later when you want to check again, you send the refresh token, you get a new access token. So they do the exact same thing. It's just this is like a long-term token, and this is more like a temporary token.
To make sure that it remembers that it is me who's asking for the access token.
So that's right. So the token itself will encode all the information about who's doing the asking and all of that type of stuff. Or Google will just has to have a database somewhere where it says this is the refresh token I gave to TripIt for accessing Jeremy's email, and then it has to have that information somewhere. So it's either it's in a database or it's in the token itself. But yeah. Okay, any other questions about this? Okay, so this is OAuth. The one other thing I want to cover in the course next class will be OpenID. And so it's almost the same thing, except for here I'm just going to log into Google, and Google's going to pass my sort of account information to TripIt or whoever the application is. So I don't have to have a separate account for TripIt itself. And roughly speaking, it's all going to happen here when it does the callback. It's basically going to say, okay, I logged this user in. Okay, so the setup is almost exactly the same, except for when I pass it over, I say I want to log the user in. Sorry, I'm distracted by this bird that randomly appeared. And then, yeah, and then it will send it back. I don't know what it is.
Is it like clipping?
I don't know if it's, I guess it's part of that app itself, so. It's like Clippy, yeah. Okay, other questions? Okay, good. So I'll see you next week. Next week will be the last class. If
This is the last class?
if my calendar's right, yeah.